eighth graders, we're going to go through lesson 7-6 today. And we're going to graph inequalities, and we're going to use the graphs to solve an inequality system. Okay? So remember, a system is more than one inequality. We did this with equations. We used the 3 different methods. Remember what we used? What were they? Brady?
Graphing, substitution, and elimination.
Right. Now, we learned how to graph and shade an inequality. We're going to have 2 inequalities, and we're going to shade them to find the area that is double shaded. Okay? And that'll be our solution. Look at this example. Y is greater than 2x minus 5, and the other one is 3x plus 4y is less than 12. Okay? And what we're going to do to solve this is just graph each inequality separately, shade it separately to find the double shaded region. Okay? So let's take the first one. 2x minus 5. How would we graph this?
So y-intercept is -5.
Yep, the y-intercept's -5. 2, 4, right, -5. And then go, what, Brady, what are you doing?
I'm getting my calculator back.
Sit down, or, okay. So what are we doing?
Up to the other one.
Up 2 over 1. Or down to left 1, right? Then, this is a positive slope. When we graph this line, we have to use a specific line. What kind of line?
Dotted.
A dotted line, a dashed line. Yep. Okay. And we need to shade this so that we can tell which area is the domain of this solution, meaning that which area is the part of the solution. Is it this side of the line or that side of the line? How can we tell, Brady? What do we have to do?
If it's true or false from 0, 0.
Okay, since it doesn't go through 0, 0,
It's false.
wait, no.
Or, no.
We can use that point to find and check that side of the line. So we can use this point because it's on a side. The line doesn't go through that point. It's on the top left side of that line. So we use those numbers and put in 0 greater than 0 minus 5. Is that true?
Yes.
It is true. Yep. So we would shade toward 0. Okay. Now you go to the other equation. And graph this one separately. How can we graph this one? Now when we're solving this, remember we treat this sign just like it's an equal sign. Okay, so you can't find like 0 is less than 12. That doesn't help you graph that. What do we have to do to graph this? Sam?
Put zeros in places of the x's and y.
Okay, but then we'd have to find something that's equal to 12. Right? So, remember, if we're using this system, if we're using this method to graph it, then we have to treat this like an equal sign. Okay?
You have to get the y by itself.
Or you can get the y by itself. Is that what you're going to say, Will?
Yes, that was.
Alright, so you go ahead and...
Okay, so you subtract 3x from both sides.
Yeah.
So that equal. That's 4y is less than 12 minus 3x. And then you divide both all by 4. And your answer is y is less than 3 minus 3/4x.
Good. I'll put it on this side. Y is less than
3.
negative, because that negative sign goes with the 3/4, doesn't it?
Yeah.
So we have to use negative 3/4 x plus 3. Okay? And so now we can graph it. How do we graph this one?
So on the y-intercept you put 3,
Good. Up 3.
and then you go down 3,
And then down 3 and
over 4.
over 4.
So right,
4. Yep.
and then that would be a dotted line.
And that's also a dashed line. Yep. And then what?
And then you choose a point.
Then can we choose 0, 0 again?
Yeah.
Yeah. And 0, 0 fit the equation? Is
Yes.
0, 0 less than 12?
Yes.
Yes, it is. So then we can shade this way. And which area is double shaded? This slice of the pie is the answer. That's the solution to the system.
How do you tell what that is though? Like how do you
Well-
give an answer?
You could check it, okay? You could pick any point in this area and it would work. It would make both of these inequalities true. Okay? Let me show you. Let's pick, well, we already used 0, 0,
So
okay?
1, 1. No.
1, 1. Any of these points would.
Yeah.
But if you picked a point up here, it would work for which one?
The y is greater than 2x.
It would work for that one, but would it work for the other one?
No.
No, it would not. Do you understand? If we picked a point down here, in the yellow region, Brady, which equation would that work for?
Y is greater than,
It would work for,
like this, like that one.
yeah,
Sorry,
Like-
I can't remember it.
okay. If we picked a point that's in this area here, it would work for the blue equation. Okay, that's part of the answer for the blue equation, but it would not work for this equation. Right? That's what that shading means. Okay? Here's another one. 2x minus 4y is greater than 12. When we solve this, add negative 2x to both sides, and we find y is less than or equal to 1/2 x plus negative 3. What happened here? Why was the inequality greater than, and now it's less than?
Because you divide or multiplied by a negative number.
By a negative 4. So we have to
Flip the sign.
reverse the sign. Right? So then, here's the graph of that, the red graph, the dashed line, negative 3, goes up 1 over 2, and we put in 0 and 0, and it made it false. So we're shading away from 0, 0. Whoops, on the green one. Shaded away from 0, 0. Okay? Look at this one. Add 2x, divide by negative 2 again, reverse the sign. So y is less than negative 1x plus negative 10. So from here you go down 1 or up and left the dashed line. And we put in 0, 0 again, and it made it false. So we shade away from that point. And then this is the area of the solution. Okay? Will?
How do you figure out like that you can use 0, 0? Like how do you know you can use it?
Good question. You can use it every single time. Whenever the line does not go through 0, 0.
Oh, okay.
If it goes through 0, 0, then we cannot use that point because it's not on a side.
Okay, that makes sense.
Okay? If it's not on the left side and it's not on the right side, this point. We have to choose a point that's on a side. So we maybe have to use 0, 1 or 0, 2. Okay? As long as the the line does not go through 0, 0, whoops. As long as it doesn't go through 0, 0, then you can use that to check. Okay? So your assignment will be on page 414 and 415.